Hello, today we're going to go over the quadratic formula, where it comes from, and the discriminant. So the quadratic formula is something that we need to have memorized. It is x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So we need to know this, we need to memorize this. The question is, where does this actually come from? So what we're going to do is we're going to take this general quadratic here. It's in standard form, ax squared plus bx plus c equals 0, and we're going to solve it. So looking at this, you might be saying, well, wait a second, solve it. There's no numbers there, which is very true, which means we cannot factor it. We also can't really graph it, so we need another method of solving. Enter completing the square. So we've been doing completing the square, so we're actually going to do that with this quadratic. So I'm going to go ahead and move the c over. I'm also going to factor out an a in my x squared and bx term. So it's going to be x squared plus b over ax plus blank in parentheses with the a out in front equals negative c plus blank. At this point, it's plus blank on both sides of the equation, because what we add to one side, we have to add to the other, which means since there's a coefficient of a, I'm going to leave that coefficient of a on the right-hand side as well, again, to keep that balance. Now, when we do completing the square, we take this middle term and we divide it by 2. So that's going to become b over 2a, and then we're going to square that. So that's going to become b squared over 4a squared. So we're going to write b squared over 4a squared on the other side as well. And so now what we're going to do is we're going to factor the left-hand side. So it's going to become an a and then an x plus b over 2a quantity squared equals negative c plus, now when we simplify this, the a out in front is going to reduce out with one of the a's that's inside. So it's going to become b squared over 4a. So at this point in time, what we're going to go ahead and do is we're going to say, if we want to get x by itself, we would normally get rid of this a that's out in front so that we can square root. So we're going to divide both sides by a, and we get x plus b over 2a squared negative c over a plus b squared over 4a squared. So now what we're going to do here is we're going to combine everything on the right-hand side. And so you might be saying, well, we can't really add those fractions, which is true. So in order to add them together, we have to get a common denominator. So this one here is missing 4a. So we're going to multiply by 4a. Now we can kind of rewrite this numerator a little bit to be negative 4ac. So hopefully that's kind of like striking some chords with you here. Okay, so we get x plus b over 2a squared equals, now when we combine them all together, we get 4a squared in the denominator, and I'm going to rewrite my numerator to be b squared minus 4ac. So we are super close. We are going to go ahead and square root both sides. When we do that, we get x plus b over 2a equals positive and negative. I'm going to leave the square root in the numerator. B squared minus 4ac is under the square root. And the denominator, the square root of 4a squared, is 2a. So when I subtract b over 2a to the other side, we are right at our quadratic formula there. So we get negative b over 2a plus and minus the square root of b squared minus 4ac all over 2a. And we can actually write those together now because they already have a common denominator. And this is exactly where our quadratic formula comes from. So it allows us to solve any quadratic in standard form without having to go through this process of completing the square. And it's actually derived from the completing the square. So kind of neat. So let's go ahead now and use our quadratic formula. So the first thing we need to know is that it has to be in standard form, and so therefore it has to be equal to 0. So looking at example 1, I have to move the x squared to the other side, the negative 3x over, and the 6 over as well. Now there are many ways of solving this, but we are focusing on the quadratic formula method for this one. So we're going to do x equals negative b plus or minus the square root of b squared, and I'm just going to go ahead and square that right away. Negative 2 squared is 4 minus 4ac all over 2a. So we're going to try this first without your calculator. So we're going to do this part under the square root first. So we get 4 minus 4, which becomes 0. So we have 2 plus and minus the square root of 0 divided by 2. So when we look at this, this is going to be 2 plus and minus 0 over 2, which just gives us 2 over 2, or x equals 1. So we end up with just one solution here, because when we actually do 2 plus 0, we get 2, and when we do 2 minus 0, we still get 2. So we end up with just one solution. Let's check out a different case. So now for number 2, I'm going to go ahead and get it equal to 0. I'm noticing since my x squared term is negative, I'm actually going to move everything to the other side. So I get x squared minus 2x minus 4. So we're going to do x equals negative b plus and minus the square root of b squared minus 4ac all over 2a, and we're going to do this without our calculator. So x equals 2 plus and minus the square root. We have 4 plus 16 under the radical, which makes it a root 20. So simplifying this would give us 2 plus and minus 2 root 5 all over 2. And we are going to break this up into separate fractions. So I would strongly recommend, if you keep simplifying incorrectly, write it out as 2 separate fractions over 2 and then simplify. Because our answer should be 1 plus and minus the square root of 5. So 1 plus the square root of 5 would be one answer, and 1 minus the square root of 5 would be another. So let's take a look at one more over here. So we're going to get everything to one side. X squared plus x plus 1 equals 0. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So in this case, we end up with a negative 3 under our radical. And before this year, you would have looked at that and said no real solution, which is true. It's not a real solution. But we can still actually get an answer this year. So we're going to do negative 1 plus and minus. We're going to take the square root of negative 1, which is I. And we're going to leave the root 3 alone because we can't simplify that any farther, and it's all over 2. So break this into 2 separate fractions. X equals negative 1/2 plus and minus I root 3 over 2. And this would be our final answer because it doesn't simplify it anymore. So we have 3 different quadratics. We got 3 different solutions. Number 1 gave us one answer. Number 2 gave us 2 answers, but they were irrational. And number 3 gave us 2 answers, but they were imaginary. What is kind of guiding that is something called the discriminant. So the discriminant is the part under the square root. So it's b squared minus 4ac. And so the discriminant was either one of 3 things in these last cases. We either had a positive number, that was example 2. When we got that positive number, we actually got 2 real solutions. So if you're imagining the graph, that would hit the graph in 2 spots. Example 1 didn't give us 2 solutions, it gave us 1 solution. So looking back at example 1, we had 1 solution when the discriminant here was 0. So another thing for this one would be if the discriminant is 0, you get 1 real solution. And graphically what that means is your vertex would be on your x-axis, so only touch in one spot. In our last example, example 3, we had a negative discriminant. With our negative discriminant, we didn't get any real answers, but we did get 2 imaginary solutions. So visually what that looks like is you would have a graph and your quadratic would not cross the x-axis at all because those ones would give you the real solutions. So even though your graph doesn't cross the x-axis, you still get solutions that are just imaginary. And to sort things even farther, your discriminant not only tells you how many solutions, so 0, 1, or 2, but they also tell you the type of solution. So if your discriminant is positive, you know you're going to get 2 solutions. But if it's a perfect square, you're going to get a nicer type of answer because you're going to be able to square root it. So you will get 2 real and rational solutions if you have a positive discriminant that's also a perfect square. So that gives you answers like 3 and -7, but it also gives you answers like 1/2 or -4/7, things like that. Anything that can be written as a fraction is rational. The next case is when you have a positive discriminant, but it's not a perfect square. You will still get 2 real solutions. So there's 2 real solutions, but because you can't square root it, they're going to be irrational. So that's going to give you solutions like 2√3 and -2√3. If your discriminant is 0, you're only going to get 1 solution, and it will be 1 real solution, but it's also going to be rational because you don't have that square root part anymore. So you'll get a number like 5 or -3/2, but you'll only get 1 number. And the last case is a negative. You still get 2 solutions. The only problem here is that they are 2 imaginary solutions. So you're going to have complex numbers with the i's in them for your solution. So we're going to take the exact 3 problems from before and we're going to identify the discriminant and tell the number and type of solutions. So you can look back in your notes if you want. Your discriminant for number 1 was 0. We did get 1 real solution and it was rational. For number 2, again, the discriminant is b squared minus 4ac. So if you go back and look at the part under the square root for this one, your discriminant was 20. And we ended up getting 2 real solutions, but they were irrational. And our last one, if you do b squared minus 4ac, our discriminant for that one was -3. We still got 2 solutions, but they were 2 imaginary solutions. So if you are just asked to identify the number and type of solutions, you don't actually need the whole quadratic formula. You can just go straight for b squared minus 4ac. So thank you very much for listening. I hope this helped.